All right. I think we have to start now. So, um, hello everyone. Today I'm going to give you a talk about what VPN to choose, and then actually let's discuss about pros and cons about OpenVPN and WireGuard because I think these are the most useful protocols that you can use for establishing tunneling, VPN tunneling between your endpoints. So, two words about me. My name is De-Monderik. I work in IT field about 10 years. In last 6 years, I work in different HFT companies. That is usually in the role of IT administrator, DevOps, network, uh, and so on. So I actually have to deal with lots of tunneling between lots of endpoints, like in between different branches of our offices and in between remote locations that are usually like financial exchanges that are located all over the globe. Uh, of course, cloud infrastructure, VPN, client-based VPN, so that our researchers and developers can potentially connect to the office and to work on their developers' virtual machines, right? So lots of tunneling involved, and today I'm gonna discuss. I actually separated this talk sections. Um, we're gonna talk about what is VPN in general, what types are there, and what types are obsolete, or maybe some of them might be used as an up-to-date version of them, and basically gonna discuss why should we prefer one types of protocols over the others. Basically, the second part of my talk would be about the use case scenarios. And we're gonna basically think of when you have to use one type of the VPN on, or maybe you want to stick to the other, or you have to stick to the other, right? And in section 3, we're going to discuss the pros and cons of the OpenVPN and the WireGuard protocols, since they are the most, I think, up-to-date, common, and robust protocols. And we're going to sum everything up and maybe talk about resources that you can read about those VPNs. And in order to configure your own tunnels, or just maybe create some scripts that you need for your work or just for a home use. So basically, this talk would be oriented for people who are just craving to dig some more information about what types of VPN are there and how to choose, and maybe just what should you read about if you want to be good, to have a good knowledge about some modern VPN protocols that you have to know on your first job or something like this. So what is VPN and what types are there, right? So basically, usually you think of yeah. So usually think of the VPN as something that is protecting your data from hackers, government, corporations that, or some marketers, right? They want to think of, uh, they want to have a bite of your data in order to, I don't know, spy on you, to give you some advertisement of some products or something. So in general, even if you're not familiar with VPN, you usually know that VPN is something about data protection and your privacy protection, right? So basically, it works like this: that that you have a VPN endpoint that might be your client over here. It is usually connected to the other side, that is server, and in between those client and server there is established VPN tunnel that might be established using one of those protocols we're going to discuss today. So that is basically giving you protection of your data that is going through this tunnel from those advertisers, governments, and hackers, right? So, but that the VPN is basically a mechanism for creating this tunnel, right? And it is securing this connection and like between either your computing device and the server or to different servers, because VPN might be like site-to-site VPN. Not only your client PC to some VPN server, right? So basically it provides you authorization. So only you can connect from your client to the server. Encryption, so all your data is encrypted. So even if someone catches some packets from your data, like internet provider or just a public Wi-Fi owner might catch some information, but it would be encrypted, so he couldn't potentially read it and understand what's your communication is about, right? And basically data integrity. So it also provides you the underlying protocols provides your a tool to be sure that your data is in data integrity is in line, right? So nothing is missing, and no one injected something in your traffic that you're sending. So that is basically three things that VPN does. So what types are there? And I actually, there are plenty of those, and potentially you wouldn't need any, all of those, of course, but you would need some of them, right? So I just created some kind of segregated in groups. So the first group is OpenVPN, WireGuard, and IPsec, right? They have different layer 2 TP and IPv2, but it's all encrypted by IPsec. These are the most common for my work. I use it in my production environment and for my home use. So this is basically every day, and those are up to date. Considered to be more up to date than some of the older protocols. So I'm gonna describe those protocols in a second. So Nordlinks and Lightway are the protocols created by some commercial firms like NordVPN and ExpressVPN. They are these protocols based on a free open source WireGuard protocol, but since this is proprietary protocols, basically it's commercial. I don't want to promote them, right? But we just have to know that those are usually based on WireGuard, and WireGuard considered to be really safe and up-to-date protocol, so they should be safe. Basically, these two provide some extra options, because WireGuard by itself WireGuard basically gives you great encryption protocol, and it's pretty fast, and it has lots of cool stuff about it, but it doesn't give you any so much of anonymity. So those commercial companies like NordVPN, ExpressVPN, and etc., they created some extra layers in order to give you some more anonymity. So they do some like double network address translation in order to make websites you're connecting to hard to understand that it was you every time you use this VPN. So we're gonna discuss it a bit later. So DTLS is and SSTP, PPTP are the proprietary protocols as well. So let's start from PPTP. It's pretty old. It's like 25 years old. It's created by Microsoft and it's obsolete. It's really outdated. It's not safe. Yeah, I'm going to talk. I'm going to give you some info about basic protocols that are used by a majority, like all commercial VPNs. So because even if you use some particular commercial option, you have to choose the protocol you're using. You usually have an option to change between protocols, or you can choose auto. But this talk is intention of this talk is to give you some understanding of why some protocols are uh, different from each other, and maybe sometimes you will intentionally choose one protocol even if you use some Mozilla VPN or I don't know some other commercial VPNs, service providers, and choose the particular protocol, not the provider, the service provider, right? So let's start with older ones just to get rid of them, right? PPTP is really old and obsolete. You don't want to basically use it anyhow. It was like Windows 95 or something, and it doesn't provide you encryption by default. So basically, there is an SSTP protocol in the third line, right? That is use SSL TLS. SSL TLS basically the technologies that are used in usual HTTPS. You know, when you go to HTTPS website, your connection is protected by TLS and SSL. SSL is secure socket layer, and TLS is transport layer security. It is pretty widely used protocols, considered to be safe. So as SSTP considered to be kind of safe, but it's also old. It is created by Microsoft and it's not open sourced. So it's hard to create an audit process of this closed source protocol. So it's kind of, you can use it if you have to, right? So if you're using Windows-based something and there's only SSTP, of course, choose SSTP over the PPTP. So what about DTLS? DTLS is a datagram transport layer security. So it is similar to SSTP in a way. It is created by Cisco, but it uses UDP packets. But SSTP uses TCP packets as an underlying transport protocol. So there is an issue with the VPN protocols that use TCP as an underlying layer. So because basically TCP stands for Transmission Control Protocol, and the TCP basically provides you some measures that ensures that traffic is going to get to its destination. And if there is something wrong with your connection during the transmission, so the first part that is sending the data, it has to retransmit the data. So there is a handshake protocol. So both sides communicating and ensuring that the other side is getting the data that was sent. And if the connection is not good, it's starting to send less data with a higher just windows, right? So it sends less data, so throughput is going down. So the issue with the TCP underlying level for the VPN is that the VPN by itself is about to do the same thing. So if your connection is not stable and your VPN trying to kind of compensate for this issue, then the TCP trying to overcompensate this issue. So this process called TCP meltdown, you can read about it if you're interested, or you can just try not to use TCP based VPNs, right? So this is known issue. So majority of different VPN protocols, they use UDP. So the UDP is just data sent from one point to another without this ensuring it gets to the point. So VPN might do this on its own, right, within the protocol. Nothing above it overcompensates. There are the last line. I just segregated DMVPN and MPLS-based L3 VPN. So those are not the protocols as well by itself, but it's rather complicated systems, should I say. So if you're into some really big corporations, or you work with network service providers, they use DMVPN and MPLS-based layer 3 VPN. So I just gonna describe roughly what it is, and you can read about it if you're interested later, because it's out of the scope of this talk. So DMVPN is dynamic multipoint VPN. Dynamic multipoint stands for if you have really complicated system of branches, offices, there are lots of paths between those points and lots of spokes, right? You have like hub and spoke architecture. So this DMVPN, what it does, it provides you an option that endpoints like on the outskirts of the system, on the spokes, they can dynamically create tunnels over the hub in order to have connectivity between each other. It involves lots of network protocols like basically IPsec that we're going to discuss a bit later, GRE for tunneling, general routing encapsulation, and might use lots of routing protocols like IGRP, OSPF, and so on. So it's kind of complicated system. If you're interested, go just and read about it. If you need it for your work, that's kind of great to know. But this what's usually described as DMVPN. So MPLS based is a thing that telecom providers use. Basically, they provide you a line, right? So you connect your, for instance, office to your branch or data center, and you order a line from your network provider. So basically, MPLS stands for multi-protocol label switching. So the key thing that the VPN packets you're sending getting routed not the ordinary way with the network addresses, rather because of the labels. So labels are used in order to route these packets. And if you're interested in how big network providers manage traffic of their clients, read about it. That is a useful knowledge. So let's stick to first line, OpenVPN, WireGuard, and IPsec, right? So IPsec, layer 2 TP, L2 TP IPsec, and IKV2 IPsec. So L2 TP IPsec was created, both of them are considered to be kind of useful these days. Lots of network gear like Cisco switches, Cisco layer 3 switches, or Cisco firewalls, or other hardware-based firewalls, like any provider of any vendor, basically usually will provide you an option to connect to your edge hardware using the IPsec. So what is layer 2 L2TP IPsec considered to be more vulnerable, and basically I think Snowden leaks was telling that NSA has a backdoor in this protocol. So if you can avoid using layer 2 TP, basically you better stick to IKV2. So IKV2 and IPsec is really handy when you're using your mobile device. Why? Because basically what it does, IKV2 is a technology that provides authorization process and creates the tunnel. But IPsec is an open standard that describing the process of encrypting your data. So basically, it is kind of open sourced, right? So IKV2, I think, by itself is just a tunneling protocol. It was created, I think, as a coalition. I wouldn't lie. I think Microsoft and Cisco was guys who created this standard, but actually it's natively supported by like iPads, iOS, right? So why? Because it is really good for your mobile devices. It really handles good when you're changing one network to another. For instance, when you use your 5G and then you're using Wi-Fi, uh, it it's great. So it will just reconnect in a second. So basically, that is because it uses uh, certificates, and it can actually issue several certificates for each connection attempt. So while you're still using your first security association and the certificate that is used for encrypting your data, the IKV2 protocol can negotiate another certificate to be used for next session, right? So that is a part of rekeying process. So basically, IPsec is an open standard, as I said, and in order to its clients for IPsec might be either integrated in your mobile device, or if you use it in a Linux environment, I really recommend StrongSwan. So there is an icon of it that is open source software, completely free, and I use it every time in order to connect to remote brokers, exchanges, even to AWS. So IPsec is a standard protocol, for instance, in order to connect to AWS. So if you have a AWS cloud, the native thing, if you want to connect with a VPN to this infrastructure, would be IPsec, right? So it's really handy to use it. It's a bit complicated. I can show you a bit the configuration over here. So there is two phases, as you can see. So it's not very easy because you have to describe encryption, hash, Diffie-Hellman group, lifetime of the session for phase 1, same for phase 2, like encryption, hash, Diffie-Hellman group. So lots of things have to be matched, right, on both sides. It can be you can use shared secret key, like pre-shared key, in order to authorize yourself. But yeah, generally it's kind of not widely used for consumers, right? So that's why you have to know IPsec and how to connect to IPsec if you about to work as an IT engineer or network engineer, because it was used like 2 decades for 2 decades, and it's still I mean, it's still used for as for now as well. So as I said, AWS is default. Any mobile device has it integrated. Usually, like even iOS. I think Windows has it integrated, but it's usually layer 2 TP. But yeah, so if it's Linux, StrongSwan is a way to go. There is plenty of documentation about it. So let's just talk about OpenVPN and WireGuard, because it's most popular protocols that are used by all commercials, VPN service providers, and I use it by my own for free because they're completely open source and great. It's hard to choose, right? So that's why I give this talk. So just one more thing. When you create your VPN, there are 2 different types of interfaces that can be created in your system. So usually it is layer 2, so it's TAN interface. It gives you virtual IP address. So when you create when you create your VPN connection, you have an interface that has an IP address. So it is created in order to your point-to-point device, right? For your device to be able to connect to some remote network or something. So usually WireGuard has only this option, but there is actually different type of interface that can be created for the VPN, and it's TAP. It's on layer 2. So here it is the picture of the OC model. So basically you can see the layer 2 is here. You have frames on layer 2, and it says data link. So it has physical addressing, MAC address. So even before your network interface has IP address given by DHCP server or manually, you have a MAC address. So every network device has a MAC address preset on the manufacturer. So some devices like I think Apple TV, some printers, some stuff like this, they use either broadcast messages or multicast messages in your network in order to connect to other devices. They have automatically like bonjour or process. They send data in layer 2 in order to establish connectivity on layer 3. So if you need this, read about layer 2 connectivity, you can create a layer 2 TAP interface using OpenVPN, or you can create a layer 2 interface if you need it. If you need, for instance, use your home devices like printers or Apple TV from remote location, and you want to be able to establish connectivity throughout the VPN to your home, for instance, or I don't know, route multicast traffic from exchange, as I do, from national exchanges from all over the globe. They send your information about prices in the multicast. So in order to get it routed, you have to create layer 2 interface. So it can be done by creating GRE, general routing encapsulation, over the existing IPsec tunnel. But let's go to discussing WireGuard and OpenVPN in the layer 3 because it's more common. So why do you use VPN? Basically, in order to get some privacy and security. So you want to, usually when you're connecting from unsafe, unsecure environments, right, in public Wi-Fi, some other guy's home or hotel room or something. So you can use VPN and service providers in order to give you the security and privacy. So bypassing local network restrictions is also a thing when you have to use VPN. Like, for instance, if you're in China or or maybe, I don't know, Russia or some other country that restricts some traffic, basically you have to use VPN, and your traffic would be routed through the other country VPN server. But you have to know that VPN only allows you this security. Sometimes it wouldn't provide you anonymity. So you have to use this maybe commercial VPNs, or think of other stuff that you can be detected with. For instance, you can use shadow socks, right? Why? Because if your traffic is just usual VPN traffic, for instance, OpenVPN or IPsec, it easily can be detected by the firewall that is used by government or corporate network, right? So it can be either blocked or it can be downgraded in the QoS, so quality of service. So your traffic will be the last traffic that will be actually processed. So for instance, if you have VPN from China, usually you would have like 30% packet loss, because firewall can detect that it's encrypted traffic, it should be VPN, and you would have a huge packet loss. So you can try to camouflage your VPN traffic so that it would look as HTTPS traffic or SSH traffic, right? SSH is the way you usually connect to some remote Linux server, right? So that's why you may use some extra layers to give you some anonymity, or obfuscation, right, of your data. Because DPI is deep packet inspection. So some cool network gear, network firewalls that can go deep inside your packet. Still, it's encrypted. They can't read what it is, but they can analyze what type of traffic it is, and they can block it or downgrade by priority. So you have to think of that if your goal is to get those restrictions passed by, right? So business remote access is pretty obvious. You just connect from your laptop or mobile device to your office to get connectivity to your resources that you have in your office or data centers. And the business batch connectivity is, we have to discuss it because in order to connect two branches, you have to use LAN to LAN or site to site VPN. So what are the difference? Basically, those are the site to site VPN provides you connectivity between two huge hubs that later can be used as a part of your infrastructure, and people should, like clients or your co-workers, employees, should be able to use this part without even knowing that, right? Because for them, it's just a private network, but actually it might be site-to-site VPN. So we're going to discuss it a bit later. So OpenVPN and WireGuard. This is as I said, top used. If you use any production, any paid VPN service, you're gonna usually use those. So what are the difference? OpenVPN is quite old. It's like it's great 22 years ago. It is kind of huge code base, so it has lots of different functionality, and 70,000 lines of code is pretty much, so it's hard to maintain, and that's why there is a more possibility of some vulnerabilities. There are no known vulnerabilities for the latest version, but as you can think, sometimes there are some vulnerabilities found, and you have to update to the new version, and it's just hard to work with a huge code base. So just keep this in mind. Other bad side of OpenVPN, it uses user mode space on Linux, for instance. So it has to translate each network request in order to the kernel in order to send the packet. So we're gonna describe it, think of it a bit later. So if you use Linux, because WireGuard is integrated in Linux kernel, so it is working faster than OpenVPN. OpenVPN can't work that fast. So OpenVPN uses as a default OpenSSL. It's really open source implementation of SSL protocol, and it uses 256 bits of length of key. So encryption is great, and if you want even greater encryption, you can set it up for 4 kilobits, right? It's a huge key, and it's hacker proof until the quantum computers would be that powerful. But every encryption that we use these days wouldn't survive in a post-quantum era. So this is best encryption, I guess, you can actually have. So OpenVPN is great with this. So public key encryption, you can use either pre-shared key, you can use password, username and password, you can use certificates. It's great, versatile. You can choose what type of authentication you want to use, and encryption as well. So great. So basically, it looks like this in a configuration file, like OpenVPN configuration file. It can have like huge certificate here. It's a secure certification authority key. Then you have your certificate here. Then your private key here, and authentication for TLS, or it's all heavily protected, right? So it's great. So another handy thing, if you're running OpenVPN as a guy who either in your home, in order to let you connect to your home resources, or you set up the VPN server for your co-workers, if you're an IT administrator or DevOps engineer, you can push configuration to the clients. That is really neat thing. So you can push DNS. So that is DNS server is used to translate your name of the site to its IP address. You can push routes. So you can either, for instance, in the same configuration, right? You can, without changing the client-side configuration file, if you're an administrator, you can just push the configuration line from the server to the client every time he connects. So you can basically alter the server configuration file, restart the VPN on the server, and every time every client would connect to it, it will get new routings, new DNS, and something. That is super cool thing. So yeah. So negotiate handshake and encryption standards every time. OpenVPN does that. So that's why connection, so the time that you need to connect the OpenVPN tunnel is a bit higher than WireGuard. So WireGuard does it in a faster way. So you just click connect, just, I don't know, second or two, you're connected. OpenVPN might take several seconds or so. So if you're just for everyday use, I'd rather use WireGuards. Just click, you're connected. OpenVPN does negotiate this handshake and encryption because basically it supports lots of different encryptions methods. And you can configure whichever you like. And client side and server side have to negotiate it, right? That's why it's also susceptible to downgrade attacks. So if you negotiate some really low or obsolete encryption protocol, so if you're a hacker and you're willing to connect to some badly configured VPN server, you can negotiate to use really poor encryption level and hack it. So you have to think about what type of encryption and authentication you use when you're creating your own server, and keep it up to date, the version of the VPN. Even in home routers like Asus or some others brands, Mikrotik or whatever, you can start your own VPN, OpenVPN server usually, and connect to it when you're out, right? And have access to your home database or something like music or whatever. So OpenVPN can be client server or symmetric. It's really cool thing. So let me show it to you real quick. So if you have some kind of infrastructure, right? This is kind of server you're connecting from, some, I don't know, in cloud or AWS cloud or something. Then you have the firewall of the company you're connecting to. For instance, it might be Exchange, right? Because I usually work with exchanges. They, exchange like national exchanges, right? They provide you, if you have your server installed in the Exchange colocation, it's not your environment, right? It's still internet colocation. It might be broker environment, some kind of environment you have your server in. So, for instance, there is EC2 server in your AWS. You connected your virtual machine in AWS to your home or office, and it's WireGuard, right? So it's all controlled. It's your AWS, it's or Google or whatever, your cloud, your server, WireGuard. You configured everything. Everything is fast and furious. So, but you want to connect to your broker. and it usually gives you an IPsec configuration because they have like old Cisco, old something, old edge hardware firewall, and it usually can be configured to accept IPsec. So you have no option, right? They just say, okay, here's an IPsec options, this ciphers, this authentication, let's go. So okay, you have to use this. I use Strong Swan on a Linux server in the cloud in order to manage that. And here they usually give you some small network because you have like a couple of servers, not so much, right? If you don't have your own infrastructure and you use brokers infrastructure, it's kind of not safe environment. They give you like small network, like /30. You have to use some network, small network here, just in order to be able to connect to this server and give this network to your broker in order to be whitelisted here on the firewall. So connectivity is established between this small network on the Exchange side and this small network on your cloud side. So what if you want to connect from your server that is installed in a broker environment, so to your AWS, and for instance, there is a database like or some other resource you want to connect to. So you usually not allowed to do this because you can't manage this firewall. Firewall is managed by a broker or exchange. So what have you have to establish another VPN from your AWS virtual machine to your hardware server that is in some particular environment. So you have to establish some VPN. I usually use VPN, OpenVPN, for the reason I will describe you right now. So OpenVPN can be client server or it can be symmetrical. So what does it mean? If this firewall only allows you to go outside, right, to connect from this Exchange server outside in order to connect to some I don't know, internet or something, but it would be firewalling any incoming connection. So VPN would work just fine because when you use WireGuard, it has to be you have to allow the port you're going to use for WireGuard on this firewall. Otherwise, the connectivity would be blocked here. So for WireGuard, you have to have incoming, ingress, and egress traffic allowed on the firewall. For OpenVPN, you can only allow outgoing traffic. So this server would be connecting to your OpenVPN server as a client. So, and the firewall would interpret this traffic as a outgoing connection and allow that. So sometimes OpenVPN can be really useful when the WireGuard just can't be used. So usually it helps when you have heavily firewalled environment and you can't do anything with this. So just keep in mind, sometimes even if you're behind the firewall, you can use OpenVPN as a client in order to connect to your infrastructure. They usually just open here port 22, right, in order to let you able to SSH to your server, but nothing else. You can't use some custom WireGuard port. You just have SSH port TCP22. That's it. All right, so let's go to the next point. Can do TAP, as I said, layer 2 for multicast, broadcast, some NetBIOS communication to your home printer, or multicast like bonjour messages with your Apple TV or something. And OpenVPN is highly configurable, so you can configure any kind of encryption. There are huge loads of those you can choose. You can run custom scripts. So you can, in your configuration file, you can say script security 2, and then just path of some script. shell script, and it will, if you allow that with a script security 2, after the connectivity of your VPN tunnel is established, it will just run some custom script. You can do whatever you want. You can, I don't know, run some additional software, reconfigure something in an automatic way, and so on and so on. So it's really cool. But OpenVPN is a bit slow. So WireGuard is much faster. So they say it might be like 4 times faster, right? On their own documentation. Let me demonstrate you. I have 2 virtual machines here, and they have both OpenVPN and WireGuard tunnels between each other. I'm running them on my laptop, so it's not that fast, but each virtual machine has 3 cores. You can see the VPN WireGuard VGVM20 has this IP address, so I will run iperf3 server in order to just iperf measure the throughput. So I would run my first test with IP address for the OpenVPN tunnel. And let's check it out. So only like it's really slow. So actually my machine is not that good. So let's run it once again. Yeah, maybe streaming consumes lots of resources. So, okay, 40 something, right? So let's try. So it's between several tens of megabits. I mean, it's not stable, but average is 35 megabits per second. Let's check WireGuard. Okay, it's not drastically faster, but you can see it's like more than 70, 71 average, right? So it's almost twice as fast. So same environment, same core count, and so on. Let me show you something. I'll run iperf in the background, and let me show you just course. So you can see lots of workers, K workers, kernel workers, when I'm using this WireGuard. So I'm running the WireGuard tunnel. Lots of cores. I use. So I have only 3 cores. So every one of them is used. So basically, that's because WireGuard is multi-core, so multi-threaded, right? So it can use all the available cores. If you have a decent server, it can give you lots of advantage because OpenVPN is just one-threaded, and it uses user space, not the kernel space. So WireGuard is a fresh new protocol. It came up 8 years ago, but in 2020, like 3 years ago, it was incorporated in a Linux 5.6 kernel by Linus Torvalds. Linus Torvalds, the creator of the Linux kernel, is pretty fond of this protocol since even included in the kernel. And since it's a part of the kernel, it runs faster. So if you want to utilize your speed, the bandwidth, maximum possible way, use the WireGuard or the WireGuard-based VPN as some commercial variants of this. So code base is only 4,000 lines. It's comparison to OpenVPN that is 70,000 lines. It's much smaller, right? So it's easier to run. It's easier to analyze, easier to implement changes, and easier to audit. So security audits. It's open source, so everyone can check this out and find the possible issue. So WireGuard, as well as OpenVPN, has known vulnerabilities on the latest version for now. So you can so it's pretty safe as well, but it has it's pretty simple configuration. So I can just demonstrate you the configuration file real quick. Here it is. I don't know if you can see it. Maybe I should just do it a bit bigger. Sorry. So that's it. So you have address. That is the address of your interface. The private key, that is the key that is used to decrypt the data you are going to receive. Listen port, the port that is your system is listening for the data. So the protocol is UDP, as I said. TCP is not that good, and you can't even change it to TCP if you want. But actually, there are additional software that you can use in order to encapsulate your UDP in some TCP if you really need it. You can need it if firewall is only allowing you non-controlled firewall, right? Some other company's firewall that you have to pass only allows you TCP, so you can kind of work around with this. So, and the peer information, the public key, that is the key that is given from the other side, right? In order to encrypt your data before sending to the other party. Allowed IP addresses. So that is basically, here is only one address. As you can see, that's the other side. But if you would add some particular networks here, it would automatically add the routes to the subnet to your system network table. That is pretty handy. And it will only allow you the traffic that between the subnets in this field. So I will get back to this point maybe a bit later. And the endpoint IP address, that is the public kind of IP address that is private because it is on my laptop, but it's not the IP address that's gonna be on your interface, but the original IP address of your instance or server, and the port you are going to connect to. And the keep alive messages, right? It would send some keep alives so that some firewalls or system wouldn't close your connection as a non-used. Okay, let's go back. So WireGuard doesn't assign dynamic IP addresses. That is kind of not useful thing. As for VPN, OpenVPN you can just set the subnet that every client would have an address from when they connect. As for WireGuard, you have to set this IP address manually in each configuration file. That is not that good, I guess. WireGuard uses only UDP, as I said. OpenVPN, you can just switch to TCP if you want. It is supported, but I'm not sure if it's a good idea. Maybe in some particular environments, you can just try that if you have only TCP allowed in some hotels, for instance. It might be useful. But try not to use this if you really don't have to. So limited backward compatibility. It's kind of good and bad because when you upgrade the WireGuard version, the encryption methods such as ChaCha20 and encryption cipher and Poly 1305 authentication, it's the only encryption and authentication methods allowed, and they're preset hardwired, no alterations. Why they chose it? Because ChaCha20 is a kind of faster on mobile devices. So they kind of thought of mobile devices and they decided to go with ChaCha20, not the AES, right? That is used for OpenVPN. Why? Because mobile devices, right? AES might be hardware accelerated on the CPUs, like desktop CPUs or laptops, but not on mobile devices. So they went, since you can't change it, the WireGuard decided to go with those encryption methods. So when there is an upgrade, they might alter the encryption methods, right, for the newer versions. And of course, older one just can't negotiate. Older versions of a client can't negotiate with a new server or to use some different method of encryption. You have to upgrade both clients and server. This is kind of safe because downgrade attacks is not possible, right? WireGuard WireGuard server stores the customer IP address on its server. So it's not kind of good, because if you're if someone would get access to your WireGuard server, or you won't use this any obfuscation methods that are provided by commercial VPNs based on WireGuard, it doesn't give you much of anonymity, right? So you have to think of this. WireGuard firewalling by default, what does it mean? So basically, as I said, you have this allowed IP addresses, right, in the configuration file that you have to set, right here, this allowed IP addresses. So it will only allow you, so for instance, here's a setup. There is a main office, there is a satellite office, there is a WireGuard tunnel between. They have a public IP address over here that is a WireGuard tunnel establishing between. Those are the WireGuard IP addresses that are on your WireGuard interfaces. So you have to, in order to make your host B connect to host A, you have to set those subnets, E5, E1 subnet, right? These two, in the allowed IP addresses on this side, and vice versa. On the main office gateway, you have to add to allowed IPs this 192.168.1.1, this E5, E1, these IP addresses. You have to add to main office and vice versa. So it should be just set manually. If it would be OpenVPN, so you can just set up, allow this address, no, I mean, not this, right? Just you can allow this site address on this site, and then just create a net over here, network address translation here, and just route and use this Linux box as a router, right? So it would be a router. So just create a IPv4 routing, and not all the traffic from this host up there, and it will be no problem for OpenVPN, right? Because it doesn't for OpenVPN, it doesn't check your traffic, where the source IP of your traffic. But if it's a WireGuard and you don't have allowed IPs in here, these are allowed not in your allowed IPs in here. No, it won't just go here, right? It wouldn't allow it to do this. So it's kind of safe, but you have to think of what you have to allow. And since the WireGuard is so small and it uses less of your data bandwidth, right? Less overhead, like from 15 to 20% data bandwidth savior. So OpenVPN would, if you use it on your 5G and you have a limited plan, maybe that's an option to switch to WireGuard again. So yeah, these are basic things about OpenVPN and WireGuard to consider. Let's wrap up, and basically you have to think of, even if you use paid VPN, or you created your own VPN server at your home, or you do it in your office, stay updated, because every old VPN protocol that is used is potential vulnerabilities. They are known, that can be used. So stay updated. whatever you choose as your protocol, right? So how to choose between these two open source, really good, secured protocols, WireGuard and OpenVPN? Of course, you have to think of use cases. So WireGuard is great if you want to get the best possible speed and throughput. So it's new, it's fast. WireGuard or WireGuard-based protocols that are used by commercial VPNs or your own setup in your infrastructure. WireGuard, it's a must if you have a tiny bandwidth somewhere and you have to utilize it all. So less overhead as well, secure. My top preference would be WireGuard, but OpenVPN is really great for versatility, right? So you can do remote configuration of your clients without updating their configs. You can change encryption to really powerful, like for 4 kilobits. You can do this client-based VPN when you're behind the firewall, so remote server can connect to remote client, should I say, can connect to a server, even if it has only outgoing connections allowed. So OpenVPN is still really great, but it's slower and considerably slower. So you just have to think of use cases if you really need that speed, or you really dig into versatility and ease of configuration, should I say, right? So what about security? It's actually really hard to decide because they both are great security. WireGuard has a bit simpler and smaller key lengths for encryption, but the organization of the whole thing, small code base, is harder to attack because attack surface is less bugs, less potential vulnerabilities. Great security as well. OpenVPN, yeah, longer key, but if it's not up to date and managed poorly, maybe it's not that secure, right? So it's really hard to decide. So I use both. I encourage you to use both. Depends on your use case, because even if you use commercial VPN, right, it usually gives you an option to choose. And sometimes you need better latency and higher bandwidth, WireGuard. You need to change to TCP because UDP is banned in your hotel by firewall. Use VPN. Okay, so yeah, there are lots of different use cases. Both protocols can be handy. So there are basically 3 websites that I use frequently. WireGuard.com. It has all the documentation about how to configure the thing. So it's pretty simple, as I showed you. OpenVPN has plenty of key like configuration lines that you can utilize. Really easy to get, powerful tool for your all of your use cases. So, and StrongSwan, I added it because it's just best possible software client for IPsec if you need that for your Linux. Usually when you connect to your third parties, exchanges, I don't know, remote infrastructures of some kind, of businesses, you're given the IPsec. Or you might have this Cisco Connect as well, of course, but it's also safe, but it's you have to use, it's a proprietary, so if you have to use the solution you're given. StrongSwan is open source. You can configure it as you wish, and it's pretty cool as well. So this they have all the documentation needed. So yeah, that's pretty much it. So if you have any questions, I would be glad to answer. Maybe if you wanted me to discuss some publicly, like, commercial options, it's actually really hard. I don't want to promote one option over the other because it might work differently and from different countries. For instance, I don't know, I used Surfshark VPN, but it doesn't work from, I don't know, from Russia because it's banned there, right? You can use Mozilla VPN, but I don't know, in some countries it might be banned as well. So it's just hard to compare, and there are such a huge loads of different VPN server providers that you just have to you just can't actually different prices as well, so you have to consider what you're willing to pay for it and so on. So you can try to have a free tier AWS EC2 instance and create your own OpenVPN server for free and try to use that as a free VPN option, right? But it's not so versatile as some paid options can be. So I just don't want to promote any of those because it's not my work, right? So I think they usually have some free options to test it, so you can just test it for a short period of time and check if it works for you. So, and then decide if you're willing to pay for the paid option or just go with free. I don't recommend using completely free VPNs that not deployed by you, because they might store your data and sell it to someone, because there is usually no free options. They kind of get their money from analyzing your data, because some of your data, because if the data is only encrypted from you to the server, and then it's getting decrypted, and they can actually see the data. This VPN service provider that is free, right? They can just analyze the websites you're going to and sell this data to marketers or whoever. So yeah, thank you so much, guys. We're a bit long today, so it was a bit longer than expected. So yeah, there are options, free options to experiment and get to your first VPN by yourself using some free tier virtual machines in some clouds or something. Thank you so much, guys. You can always find me on LinkedIn and add me in Telegram. If you have any questions, we'll be glad to answer and dig some more information about it. Just let me know. Yeah, let's keep in touch. Bye. Cheers.